Good morning, teachers and fellow classmates. Today my group will be presenting to you about the mysterious physics law, the law of conservation. My group members are, there's Hongzi, Anthony, and Bo. Now Anthony will continue with the technical aspect.
So basically, we are going to demonstrate the mechanics of a Gaussian gun. In the Gaussian gun, you make use of the conservation of momentum and conservation of energy. Remember, the first law of thermodynamics states that energy cannot be destroyed or created, only converted into other forms. So in the case of the Gaussian gun, we are converting magnetic energy into kinetic energy. This will be shown in demonstration later on.
As you can see here, we have the prototype of the Gaussian gun. What we have here is magnets. You can see taped to the track, and each magnet has 4 ball bearings with it. And the more magnets there is, the stronger the propulsion of the ball bearing will be. Fixing the magnet to the track so that we can make sure it doesn't move when we hit it. But keeping it still, we make sure that most of the energy is transferred through the magnet and into the ball, and no energy is lost on the way. And in addition, we are putting 4 sections of these magnets so as to increase the amount of acceleration that the balls get, and hence, as a result, makes the ball come out faster. Simply by rolling this ball bearing towards the first section of the magnet, the energy will be transferred throughout all the ball bearings into the last one, and it will be shot out towards the bottle. As you can see here,
Mr. Egg will now sacrifice his life for this demonstration. Following the in-depth exploration of the mystique law of conservation, we shall continue with the follow-up by delving deeper into this topic. The Gaussian gun, as mentioned previously, incorporates the law of conservation of momentum and energy. Let's take a look at a similar model which demonstrates this, the Newton's cradle. When n number of balls suspended from a metal bar, knocked into the remaining balls when lifted, would result in the same number of balls being ejected at close to the same velocity, while the previous balls would be stationary. This is because the momentum and energy from the balls are transferred through each ball, and due to the conservation of momentum, the speed of the balls will be close to the same. In the case of the Gaussian gun, the law of conservation remains in place as a single ball is added to the system and a single ball being released at high velocity. However, with the presence of magnets in the system, the magnetic attraction between the ball and the magnet will lead to the ball speeding up while traveling towards the magnet, ultimately resulting in the ball bearing hitting the magnet at an extremely high speed, explaining the high velocity of the last ball.
No risk of harm in making